Hello, everyone. Today I'm going to talk about my research in the GC4 project, namely the conversational AI. My name is Yiwei. I'm now doing my PhD in the ID lab. In our work, we focus on a task-oriented dialogue system based on procedural knowledge. For this title, you may have two questions. What is a task-oriented dialogue system, and what is the procedural knowledge? So let me answer the first question. What is a task-oriented dialogue system? I suppose that most of you must be familiar with one of the products below, like the Amazon Alexa or the Apple Siri. They can help you to do a lot of things very cool, like playing music or scheduling your calendar. They are all designed to help people accomplish a specific goal. So that's why we call them task-oriented dialogue systems. And in our case, we want to establish a dialogue system on unstructured texts. And more specifically, we focus on procedural documents like cooking recipes or chemical processes. And imagine that we are going to build a dialogue system that can help people to cook. At the first step, we need to extract important information from these unstructured recipes, right? That is the procedural knowledge. Then we build conversational models with machine learning algorithm. And of course, we need tons of conversation data to drive these models. Then combining these models together, we will have a smart assistant in the end. But here, there is another question. How do we combine these models? Or to say, how does our dialogue system work? This might be a little bit complicated. I will try to explain it step by step. As you see in the right, there is a recipe text. And for each recipe, we give unique identifiers to the title, ingredients, instructions, and all the highlighted entities within sentences. And in the left, there is a conversation generated by our annotators. So let's have a look at the first question. The user is asking, "Hi, can you tell me the recipe name?" Our system will parse this question into a semantic frame, which includes the user intents and two-step identifiers to track the user's state. Then our model will predict the action frame for the agent, that is a sequence of executable functions. And finally, the model will use this action frame to generate natural replies to the user's question. So to wrap it up, our system is composed of 3 steps that makes sure our dialogue system can interpret the user's intent precisely and generate the meaningful replies. So what about next? Well, in the previous slide, I have shown you one cooking dialogue. And in the last year, we have collected hundreds of these dialogues based on different recipes. We compiled these conversations and documents into a new dialogue dataset that will be released in our new publications. At the same time, we also trained several conversational models to develop a demo. And our plan is to invite more users to test this demo in terms of the generated response fluency, coherency, and etc. So I think it's time to close this presentation. I post my email in the left corner. If you have any question, just let me know. So, bye.